Hello everyone, my name is Franco Pucci. I am the technical consultant for the STS Association and I've been involved in the prepayment industry for over 25 years. Welcome to the STS training video series where we will explore all aspects of the STS and the STS standard. I hope you find these videos helpful. In this video we will deal with section 6.3 of the IEC 62055-41 edition 3 token data elements. The reference source for these videos is the 62055-41 edition 3 document. So you can refer to table 13 clause 6.3.1 in the document for a summary of all the token data elements. But first let's just have a look at the classes of tokens. Token class 0 is for credit transfer, units and currency, and this token class is encrypted. Token class 1 is for non-meter specific management tokens, and this token class is not encrypted. Token class 2 is for meter specific management tokens, and this class is encrypted. And token class 3 is reserved for future assignment by the STS Association, and it may or may not be encrypted. They have not yet been defined. Let's look at the token subclasses in 6.3.3, table 15. So subclass 0 is credit for electricity, and this is in token class 0, subclass 0. Token class 0 subclasses 1 to 7 are all credit tokens for electricity, water, gas, time, and all of the currencies, and token subclasses 8 to 15, that's down there at the bottom, are reserved for future use by the STS Association. Token class 1, subclass 0 is a meter test for 2-digit manufacturer codes, and subclass 1 is a 4-digit manufacturer code test token. Subclasses 2 to 5 are reserved for future use. Subclasses 6 to 10 are reserved for proprietary use for 4-digit manufacturer codes, and subclasses 11 to 15 are reserved for proprietary use for 2-digit manufacturer code meters. Remember, class 1 tokens are not encrypted. Then we have token class 2, which are encrypted, and I'll go down from subclasses 0 to 15. You have set maximum power limit, which we've discussed already, clear credit, set tariff rate, which is a reserve token. Then you have the set first and second section decoder keys, that's our key change tokens. You have a clear temper token at subclass 5, and then you have the set max phase power unbalance and set water meter factor, also reserved. Set third and fourth section decoder keys at subclasses 8 and 9. Subclass 10 is reserved by the STS Association, and subclasses 11 to 15 are reserved for proprietary use. And then the whole of token class 3 for the moment is reserved for future use by the STS Association. Let's talk a little bit about the random number that keeps appearing in all of these tokens. That's in section 6.3.4. The generation of this 4-bit number is a snapshot of the 4 least significant bits of at least a 1 millisecond counter. This is done internally in the security module. You have no control over this at all. It enhances the security of the token transfer by providing a probability of 16 to 1 that no two tokens containing identical data will have the same binary pattern when it's generated. The random number is implemented in a hardware security module, as I've mentioned already. Now we need to note that currency tokens do not have a random number, since this is used as the sign and exponent bit for the currency transfer amount, which is a lot larger than in a normal unit amount. You know, we've spoken about token identifier quite a bit, but it's probably worth going through it again. It's derived from the date and time of the issue of the token, and it represents a number of minutes elapsed since the start of the base date. It's a 24-bit binary field, giving 31.8 years since the base date's start. The date and time format is year, month, day, hours, minutes, second, where the seconds can be truncated from the time. They are not actually used in the generation of the TID. The table below shows for different base states the minutes elapsed and the 24-bit TID field. With 0 minutes elapsed, it's all 0. With 1 minute elapsed, it's 1. And with whatever that is, 167 million minutes elapsed, or 16 million billion minutes elapsed, that is corresponding to the end of the base date, 24th of November 2024. It's all ones. In other words, it's full. The same can be said for the 2014 base dates, which stretches from 2014 to 2045, and the 2035 base date, which stretches from the 1st of January 2035 to the 24th of November 2066. So every token we get, we store the TID value in a meter TID memory, or memory stack, or whatever we want to call it, TID memory stack. How does this work? Well, if no tokens have been entered in the meter, the TID memory contains zeros, or the manufacture date of the meter. You enter a token with a TID value of 00001. The stack moves down by 1, and the 0 that was in position 1 moves out of the stack and gets deleted, and the TID of the token you've just put in goes into position 50. As you keep entering tokens, each with a different TID value, the stack keeps moving down until you get right to the end and you've entered 48 more tokens, and you now have tokens 1 to 50 stored in your TID stack. What happens with the next token? Well, the moment you enter the next token, token number 51, then the first token 0001 is deleted from memory. If the next token has a TID value of 001 after this, the meter sees it as old because it is older than the oldest token that's in the TID memory. Remember, the token 00001 was removed. It's no longer in the TID memory. So if you put a token with a TID value of 1, it is definitely older than the token in position 1, which is 000002. If the next token entered has a TID of, say, 000004, the meter sees it as used because it is already contained in the TID memory. So that's essentially how old and used works in the TID memory, and that is a way of effectively deleting tokens once they've been accepted. With a magnetic card, it's easy. You simply erase the magnetic card. You also do this operation, but that is a token cancellation. There happens by erasing the magnetic card and the TID stack. With a keypad meter, obviously you can't erase it, so you essentially do this. Okay, so old, if the next token is older than the oldest token in the stack, and used if it already exists in the memory. There's also a special reserved token identifier, and you can look that up on 6.3.5.2. The TID corresponding to the first minute of each day is reserved for special application tokens. It must not be used for any other token. So the reserved TID value corresponds to a year, month, day, and 0001 of every day. The seconds don't matter. If a token other than a special application token is to be generated on a time corresponding to this reserved TID, in other words 1 minute after midnight, then 1 minute must be added to the TID by the point of sale. So as a normal credit token or management token, you can never have a token or generate a token with a TID value with a time value of 1 minute after midnight. Your point of sale must increment this by 1 minute on its own. The use of the special reserved identifier is optional, but the rules on how to use it are not. So if you're going to use it, you need to look at the specification to make sure how it's handled. The usage, typically it's, for example, you could have 50 kilowatt hours each month of free electricity. The token can be collected at any time of the month. It doesn't matter because the TID value is always 1 minute past midnight. And you can collect it as many times as you want, but it'll only ever be accepted once, simply because once it's accepted, the meter can see that it's already been accepted and it will not accept it again. We have multiple tokens generated within the same minute. This you can find referenced in 6.3.5.3. If multiple tokens are generated within the same minute for the same payment meter, 1 minute must be added to the TID of each successive token in the set. So in other words, if you generate 3 tokens within 1 minute, starting at 3 o'clock, the first one will be 3 o'clock, the second one will be 3:01, and the third one will be 3:02, although you've generated them within 1 minute. At the end of the token generating process, once it is completed, the point of sale reverts back to real time. This does not apply to tokens that implement the special reserved identifier we've just spoken about. So if the first token is 1323, the timestamp will be 1323. If token number 2 is also generated at 1323, it will have a TID of 1324, and the third one will have a TID of 1325. This brings us to the end of this part of the video series. I hope you found this video helpful, and I hope you will join us for the rest of the series. Goodbye and see you again soon.